It might be stuck in your book. I didn't even realize I took home all this stuff to grade, and I unzipped my book bag when I got here to pull out my laptop and went, whatever. All right, so we're going to use implicit differentiation to find the first and second derivative here. So the derivative of x squared, 2x. What's the derivative of y squared? There you go. You got to do the dy dx since I'm taking it with respect to x. And the derivative of 1 is 0. And so now I solve for dy dx. So I get 2y dy dx equals negative 2x. And then, of course, divide by 2y. So dy dx is and this I'm going to use as I find my second derivative. I'm probably even going to change this to use product instead of quotient. Oops, I'm sorry. I forgot to cut it off. All right, let's do second derivative. And then what I said first and second. Second derivative. Okay, I can get back in the swing of this. All right, product rule, derivative of the first times the second plus the first. And then derivative of the second, what's the derivative of y to the negative 1? Negative y to the negative 2 y dx. It's solved already for the second derivative, but that didn't go away even over. Right. I need to plug in dy dx here, right? Because I don't want dy dx in my answer. I only want x in the y. Jalen, you look a little sleepy. You good? All right, so I'm going to plug in, and I am going to have negative y to the negative 1 plus negative x, negative y, negative 2, and then negative x, y, negative 1. Gross. That's okay because it's all multiplication. So no distributing here, right? Because I'm just multiplying. There's no addition or subtraction. So it's just negative y, negative 1. Oh, I got 1, 2, 3 negatives. Minus 2 x's and negative 3. If I wanted to, I could put this into a fraction and have just one. I don't know if that's the way they did it in your book or not. Yeah. This would be negative 1 over y. This would be x squared over y cubed. So this one needs what? Y squared. So I end up with negative y squared minus x squared over y cubed. Oh, that is smart. They went a step further. See anything else you could do? Let me zoom out a little bit. Exactly right. If you take a negative out of here, right, it leaves you with y squared plus, I would have never thought to do this, to be perfectly honest, unless I was on a multiple choice and I saw that none of my answers matched. I'd be like, In the beginning, it defined x squared plus y squared as being 1. So I could put negative 1 over y cubed. Did any of y'all get that? Yeah. Did you think to do that? Did y'all think to do that in the front? Wow. I wouldn't have thought to do that in the beginning. I would have gotten there. That's as far as I would have gotten. All right. What about the rest of your work? Anything that kind of brushed some of the cobwebs off? Y'all look dead. Just dead. Tonight. Yes. Um, find dy dx, yeah. Do you know now? Does that make sense? So the hardest part is going back, plugging in that dy dx. That's what you end up having to do. I'm telling you though, that I would have never done that initially, unless I was in a situation where I couldn't get my answer to match, and I'd go back and look. This one? Did you get this far? So again, unless you're in a multiple choice situation, I mean, this is acceptable. There's nothing wrong with that. This is just more simplified because I put in one fraction. So, okay, let's do a couple more examples. Let's do a couple more. Did we do these tangent and normal lines yet? I have that written down for us to do together. No? Yes, no, maybe so? Prior to, like, mm-hmm. This one's going to be with dy dx, I'm sorry. Find the equation of the tan line and the normal line to the curve at that point. Tan and normal at that point. This is still implicit differentiation. What should I do? Find the derivative. Remember, when in doubt, find the derivative. It's going to do something somewhere. So let's find the derivative. Derivative here would be dy dx, right? I don't want to go through and try to solve this for y and then take the derivative because gross with all this I have in here. But let's go ahead and find the derivative. So here, product rule, yes. Derivative of the first is 1 times the second plus the first. What's the derivative of sine 2y? Y'all can do this. What's the derivative of sine? Cosine. But I leave the 2y alone. And now I do the derivative of the inside, which would be 2 dy dx. Remember, if you take the derivative of y, make sure you follow it with dy dx. All right, same thing. I did product rule. Yeah. Now I'm going to do the same on the right side. So derivative of the first, what's the derivative of y with respect to x? 1 dy dx, right? Times the second plus the first, derivative of the second. So derivative of cosine 2x is a little bit easier. Sine negative sine 2x. And don't forget the chain. Are y'all okay? You sure? I need all my dy dx's on one side and everything else on the other because I'm going to factor that dy dx out. Remember, I want to solve for that. So this one's going to come over here. This one's going to come over here. So I have x. Actually, I'm going to put these together. 2x dy dx times cosine 2y Well, this is multiply, this is multiply, this is multiply, right? I just put, yeah, I'm making it look a little prettier. And now I'm going to subtract this one, so minus dy dx cosine 2x. I see some unit circle stuff coming up. I know that excites y'all so much. This is going to be negative 2y sine 2x. And I need to move that sine 2y over. It's Henry's fault. He said take the derivative. Factor out a dy dx so we can have the derivative dy dx times 2x cosine 2y minus cosine 2x. Now what? Divide. Divide. We'll rest here just a second. Let you catch up with me after I write it. Nothing's been too terribly hard. It's just so much. You gotta keep up with your little pieces. Yes, ma'am. This one's this one. I think that's what you're looking at. I can plug in, I can find the slope, and then I can write my equation of my line, right? I already have a point, so that's nice. I don't have to go in and plug anything in. I've got my x and my y. So really all I need is a slope. The derivative will give me that. But I've got a nasty derivative here. And I am plugging in pi over 4. What was my other point? Pi over 2. So the slope of the tan line yes, this is your x and this is your y. So your slope of your tan line at this point, pi over 4, pi over 2, is going to be. And now I'm going to plug in my x and y. So here's where it's going to get nasty. Negative 2, my y is pi over 2. The sine, 2 times, now I use the x, pi over 4, minus the sine of 2 times, the y is pi over 2, over, the x is pi over 4, cosine 2, the y is pi over 2, and then pi over 4. Clean it up a tad here. This actually becomes pi over 2, which is a nice little point on my unit circle. Where's pi over 2? Right at the tippy top, right? So at the tippy top there, what is the sine value? 1. So the sine of pi over 2 is 1. Minus, here, this would be the sine of pi. Where's pi? 180 degrees straight across. What's the sine there? 0. There's no y value, right? There's no height to it. So minus 0 over pi over 2 times, again, this is just pi. What's the cosine of pi? Straight across, negative 1 minus, this would be pi over 2. What's the cosine of pi over 2, 0, straight up. I'm pointing like y'all know what I'm doing. Now it's a lot easier to work with, right? I have negative pi over negative pi over 2. So all I'm going to do is multiply by the reciprocal here. And I have negative pi times 2 over negative pi. What is the slope? All of that for a slope of 2. Isn't that crazy? So my slope is 2. I still have not answered the question that was presented to me, which was, what is the equation of the tan line and the normal line at that point? So I have a slope. They were nice enough to give me the entire point to start with. This is the slope of the tan line, not the slope of the normal line. The point, of course, being pi over, pi over 4, pi over 2. Oops, I should do it like that. I should do tan How about normal? What's the difference? There you go. Negative 1/2. It's going to be the only difference there. What you think? Easy? There's no part of it that's really hard. It's just there's so stinking much, right? I mean, that's a lot. Let me give you one to try. Did we? I think we might, for some reason in my notes, I got us starting at 24. I'm thinking we might have stopped at 23 writing the equations. Because they get hard after 23. Like the dy dx? Oh, this was my answer so that we could find the slope. That's because Noah broke the air conditioner. Noah broke the air conditioner. And just wait. You don't think they're fine?
I know how to do it.
Tangent, normal line through that point. Mark, set, go. Remember with your trig function, it's power trig inside. So be careful with your chain rule on that one because that's a cosine squared. You're going to have to chain that y. It'll be 2 cosine y times the sine of y, or negative sine of y, times dy dx. A little less confident now. Once you have dy dx by itself, go ahead and plug in your x and your y and then simplify. 0 and pi. And that might make it a little easier. I'm going to go ahead and set up the first step for your derivative here because if you mess that up, then the whole problem's just from there. So I'm going to do derivative of the first times the second plus the first times derivative of the second, 2 cosine y times negative sine y times dy dx. If I had to guess anywhere you messed up here, it would have been that dy dx left off there for the chain. Well, and that's fine because it's all multiplication. There's no. All right, minus sine y dy dx. Cosine y, that's what I said. dy dx. So now everybody can give up a dy dx. All the dy dx's are on the same side together anyway. Oh, nope, I got to move that one first. Just kidding, I lied. Wait, what? Yeah. So this one's going over here. So I have negative. And in fact, I think what I'll do, I don't want to confuse everybody, but because everybody will be negative when I move this over, I'm going to go ahead and make everybody positive. I'm going to divide everything by -1. Well, when this moves over here, he'll be, well, there's a negative sine y here. You see what I'm saying? So everybody, and then this is going to become minus because of this minus. So are you so cold? So what I'll do is I'll just keep everybody positive now. So I have 2x squared cosine y sine y dy dx minus cosine y dy dx. Oh, plus, just kidding. 2x cosine squared y. Yes, ma'am. No, because there's no plus in there. I dropped all the negative because I had a negative here, a negative here, and a negative here. So I just divided by -1 everywhere. Made everything positive. So now I have dy dx times 2x squared cosine y sine y plus cosine y. It's the stinking algebra every time. No, I just did to make my life a little easier, but no, you don't have to. Everything would have a negative sign in front of it if you didn't. That's okay. That's all right. You don't have to. I'm going to divide here. Should still come back to the same thing. 2x cosine squared y over 2x squared cosine y sine y. Yeah. Because this piece had it and this piece had it. If I wanted to go backwards, yes, it would go to both. But what I did was I just divided both sides by this piece. And that's why it's on the bottom now. It's outside. I could put it, it doesn't really matter where it is with since everything's being multiplied here. The parentheses really aren't relevant if you're talking about up here and that step above. None of that step below. It doesn't really matter if it's in here with it or outside since there's no plus or minus there. But again, you want a plus or minus. So see, I could distribute in this step because of the plus that's inside here. But since this is just multiplying everywhere here, I couldn't distribute. Right. So now that I have a nice, pretty dy dx equation, I can find my slope, and my point was 0 pi. Oh, really? Is the slope 0? Dang, y'all, we don't have to go any further. You put a 0 in right there, it doesn't matter what else is there because you're multiplying by 0 up top. That means slope is just, that's nice. Check the bottom and make sure it's not undefined. Yes, that's probably smart. This is going to be 0, but then the cosine of pi, -1, so we're good. But yes, you are correct. That would be smart. No what? Well, pi and pi over 2 are really easy. Pi over 2 is at top, pi is over at the left, 180 degrees. So think about your x and your y. Cosine is x. So it's -1. That's still not the equation of the line, though, right? So the tan line, y minus pi equals slope times x minus 0. It really doesn't matter here. So y equals pi is my tan line. What about the normal line? Same. Actually, the normal would be undefined slope, right? Right? Because this is a horizontal line, so your normal line is going to be a vertical line, so your slope is undefined. So it'd be x equals 0. Right? If it's got to go through 0 pi, and this is your tan line, and your normal line's got to be perpendicular to that, x equals 0 would be your normal. I told you. I told you I could make it come on, but you might regret it. Are you really? It's supposed to get down to like 30-something degrees either tonight or tomorrow night. I know. But the high tomorrow is what, yeah. I'm so ready for it to be cold. So excited. I'm going to open my windows at home and freeze everybody out. And when they complain, I'm going to tell them to get a jacket. Wrap up in a blanket. It has. Do y'all have the air conditioner on? We have the air on at my house. But that's not. Oh, City of Camden's killing me. I can't afford to put it on 68. I told my husband, I was like, we're just going to have to put the fans on a little higher. Listen. Oh, my goodness. Well, I'm kind of digging my heels in now that it's like the point of the matter now that I'm not paying $800 for a heat and air bill. My gosh. What the heck? So now it's, yeah, crazy right now. Let's do one more and then I'll set you loose. This is one of those wordy problems that you have to dig through everything. I'm trying to think if I should do this one or 47. 47? Have you looked ahead? On 47, you read the first? Oh. You're talking about 46? The cissoid of Diocles. Yeah. Okay, but 46 is like they give you this heading. It's kind of like whenever we did. Yeah. But they give you an equation. It's like y squared times 2 minus x equals x cubed. And it tells you to find the equation of the tangent and the normal line at a point. So it's just got a bad heading to it, but it's not really anything. I think 46 is harder than 47. Okay, find an equation for the tan line and the normal line to the cissoid of Diocles, given by this equation, at the point 1, 1, as pictured below, but it really doesn't matter. The picture is irrelevant because I don't need the picture to algebraically find the tan or the normal line. Tell me what y'all's thought process is here before you start. Find the derivative. Hubs has put the x third on the left. Does anybody have any other ideas on how you're going to start? Or did you just jump straight in? I say you could do whatever you want, whichever way is easier for you. That's why I asked which way y'all would. My first thought was, I'm going to distribute that y squared and try to get some things together. But then I was like, but if I do product rule the way it sits now, I don't have to chain any x's. I'll only have to chain the y squared, the y's with the dy dx. So I might leave it and do product rule. Tan and normal. This is 46. I'm almost there. Yeah. Is it mine? Whose is it? Yeah. I think I don't need it. I thought it was yours. Did you come back to the same slope? That's fine. You just plug in before. That's fine. That's perfectly fine. What'd you do? There's your tan and your normal. Yeah. That one wasn't bad. Was what?